where did this shape of the formula come from? All right. So the explanation I thought about is not self-contained. It's not easy to just understand in what we have so far discussed. So I'm going to go beyond a little bit. Is the idea of a rotation. Here is a unit circle. Actually, it doesn't matter if it's unit circle. So I'm going to explain. I have a random position here, x comma y. Right? Then it has its own distance from here to there. This I label it, I explained, as a matrix explanation. It's not a proof. With gaps, it means there are certain things I'm just going to say it and not really be able to explain it. All right, I'm going to rotate this x comma y around the origin by angle, let's say theta. I'm going to do angle S here. Then you arrive at somewhere here like that. It keeps the kind of radius there, right? It's the same. And you arrive at here, x comma y comma. And if you look at it as a motion, this is going to leave this type of trace. Does that make sense? You move it like that. The question is that I give you x comma y, and I give you s radian, and can you calculate this new coordinate? That is the question first in hand. And it turns out this is the transfer. This application is transfer, every point is rotated by s radian. It's the transformation. This transformation has interesting properties called linear transformation. It's not really complicated. It's really easy to understand the transformation. That's the part I have to wave my hand. I'm not going to explain it further. So all I want to know is a formula. I want to know formula. So what is the formula? I give you an x comma y, and what is this x prime y prime? This is a matrix algebra. All the linear transformation is explained through matrix algebra. You've seen the movie Matrix, right? In the background, it has a matrix shape in there, although it's kind of drilling down. The two coordinates, they use this matrix. Like this, it's a 2 by 2. You have 2 slots in a column and 2 slots in a row. So altogether, 4 slots of a number going in there. Using the linearity, which is a pretty neat thing, and using the structure of a matrix, you actually get this formula really easily if you understand this fancy linearity property. All right, so 4 numbers going in there in the formula. The first number turns out to be cosine s. Second number in the right upper corner turns out to be negative sine t. Lower left corner gets sine t, and lower right corner gets cosine t. So there's this 4 number. We're going to do something with this 4 number to that x comma y to get this coordinates, right? All right, what are you going to do? You write that x and y right next to it like this. That's the coordinate here. And they put this bracket and multiply these two things like that. If you know what a matrix multiplication is, it's going to make perfect sense. If not, I have to explain how these things come about. Matrix multiplication go like this. X go over here and y goes over there. And you multiply x down the road, down the row, and y multiply down the road there. So we get following expressions. 2 by 2. You write cosine s times x. You multiply there, and x there is a sine t times x. Okay? And here you multiply negative sine t times y. Multiply y down there, cosine s times y. And you bracket. Doesn't it still look like a matrix with the different 4 entries? But it is supposed to be this coordinate. So next step you do is that don't look at this as a matrix, but put them really close to each other like that and add them together, whatever the sign preserved. Do you see this is a 1 number? Before it was a 2 separate entries. Now I add them together, it's a number. And down there is number. And that becomes x comma x prime. That becomes y prime. That is a formula that's coming really easily out of this linearity and matrix algebra. So you have to accept this. X comma y rotated around the origin by s radian. The formula is this cosine s x and blah blah blah. That's the formula. Okay? So I'm going to do it 2 times. You're going to first rotate s radian, right? Then what? To t radian. That's what we're going to do. So here is our picture. Circle. Like that. And we're going to go first where? S radian here, right? What is this point here? 1 comma 0. Thank you. And so on the unit circle, you go s unit first, s radian first, right? And at that point, we're going to call this one x1, y1. Okay? You arrive it there. And from there, we go t radian more. And then we wonder what that eventual goal and x2, y2 is, right? So what is y2 there in terms of s and t here? Sine coordinate, sine, because y coordinate is a sine, right? Y coordinate is a sine. But what is the angle? Angle is not 1. We first go s and then go t more. S plus t. Isn't that what we wanted to know? Right? How about x2? Cosine of s plus t. Alright? So that's what we wanted to know. What we're going to do is that you use the matrix, go 1 step at the end of the s radian, and from there we go 1 more to t radian. So what is the first point? S radian rotation is the first step we're going to do. The point is written vertically like this, 1, 0, right? Now, some of you have this photographic memory of just that matrix I wrote down. Remember, upper left corner, what was it? Cosine s. Right corner, negative sine t. Down here, sine t and cosine t. So what do we do with this 1, 0? You write 1, 0 up here, right? And multiply down the row, down the column there. So what is it? First one is cosine s. Down there is sine t. We just multiply 1 there, right? How about 0? How convenient. They all knocked out. This is a new point. That point x1, y1 is this one in here. This is x1 and that's y1. And that's a dumber. That's because x1 is a cosine s and y1 is a sine s. We already know that, right? But it recovered that. You know just what happened? This is the standard position angle s. x1 is supposed to be cosine s. Sorry about this. This is supposed to be all s in there. Oh, it's a mistake. It's all s. There's no t yet. We didn't rotate t. Sorry about this. It's all s. So if that, then it is of course that. Next step is non-trivial. It really is. We are here, right? So, and the t radian further rotation. Okay? So where are we in the immediate step? Cosine s, right? And the sine s. That's where we are. And we go how many angle more? T angle more. T more. So this is going to be cosine t, negative sine t down here, sine t, cosine t. Now we're going to multiply through and put them together and see what the coordinate you get. Let's do that. So I'm going to put them down. So you write cosine t up there. That's your intermediate x coordinate, and sine s there, right? Multiply down the column. Then what do you get? Cosine s times cosine t. And they're add them together, and let's do that down here first. Sine t times cosine s. How about this one? We have to put right next to it so that we see the whole thing. Sine t times sine s. Down here, cosine t times sine s. Right? That's the final coordinates. These guys are x2 and these guys are y2, right? What is the x2 supposed to be? x2 is supposed to be cosine of s plus t, right? So does it look like cosine of s plus t right there? Haven't you seen that before? What is that called? This formula here. Addition formula? Right? Cosine, cosine, sine, sine? That's the addition formula. It's a cosine of s plus t. That's x2. That's a x coordinate of the terminal point, s plus 2. S plus t in there. How about this guy here? The sign, s and t is mixed up a little bit, but you can rearrange it and get the result. So why did I do this? Is to show you where this, cross multiplication come from. Where this, where did that come from? This one matrix multiplied to another 2 times and come about like that. So just there's a guy in the street and describe you, ask you, why does it look like this, cross multiply like this? And your short answer is that's how the matrix multiplied out, right? That's how the 2 by 2 matrix is multiplied out. That's why it looked like that. I think it's still dissatisfying because it's not a physical intuition that you get why they mingle together like this. Quantum mechanics is written in terms of complex variables, and this is really the complex algebra, and it is beyond everybody's way to juggle things. So nobody try that. Just obey the law of this mathematics and just deal with it. Don't try to think about it too much. But we got to keep trying. Next semester I'm going to try something even further, see if we can actually use some sort of physical intuition to see if this is really happening. Maybe a few more semesters I'll get really better, but it's a hard part to kind of bring the physical intuition to this formula. But by the end of the session 3, you take this under control and be able to write down. So usually I hand out the test and then everybody just go to their problem that says state the addition formula. Everybody just quickly write down before it disappears, and then of course you have to do that problem based on that formula, right? And there are students who write down wrong formula, and everything else your test is depending on that wrong formula, then you're in terrible situation. So make sure you get this one under control. Like I said, I don't want to give you the formula sheet just looking at it and plug and chug, nothing like that. Understanding the structure of a formula by just thinking about it like this, it is an important part of understanding spectral decomposition and all the other trigonometric analysis that's coming. Alright? Okay, that was it.